Okay. So here's problem 7. A circular spinner has 7 sections of equal size, each of which is colored either red or blue. 2 colorings are considered the same if one can be rotated to yield the other. In how many ways can the spinner be colored? And so here, there's sadly nothing fancy you can do. Like you can expect that there won't be that many ways to do it, just because you have like 2 choices out of everyone, and you can rotate, which will massively cut down on the number of choices. For example, there's approximately like 2 choices each, so 2 to the 7th, different coloring, rotate them so that we rotate it, and like each like unique coloring will be repeated at least 7 times. So it'll be approximately around this, which equals 128 over 7. Actually, it'll be slightly more because some things can't be rotated. So that comes out to 128 over 7, which is equal to like 18. So yeah, you know there's going to be around 18. I'll write the spin meter. You know there's going to be approximately 18 colorings just beforehand, which means that you can probably just count them by hand. So let's do that. What if there's 7 reds and 0 blues? In which case, there's only 1 possible coloring, just all red. What about 6 reds and 1 blue? Once again, just 1 coloring. We just rotate the blue into one fixed spot and they're all the same. What about this 5 reds and 2 blues? Well, here, what it'll come down to is the distance between the blues. So there's a couple ways to do it. Firstly, we could have 2 adjacent blues, or we could have blues that are 1 apart, or we could have blues that are 2 apart. But if we have blues that are 3 apart, we can just rotate it. Unfortunately, if we have something like this, we can rotate it to here, and it's the same as our 2 apart case. So our only choices are to have blues next to each other, blues 1 apart, or blues 2 apart. So that gives us 3 choices. And now our last case before we can just start using symmetry is 4 reds and 3 blues. So we have our 3 blues. So we break this down into 2 cases. Case 1, no adjacents. So in this case, we'll have like here, here, and here. And this can in fact be rotated. We can always just rotate this block of 2 up to the top, and boom, they're all such colorings are going to be the same. So this will give us a 1. Now, what if we have case 2, 1 pair of adjacents? If just there's 1 pair of adjacents, so we can always rotate this pair of adjacents to the top. And now we can choose to place it here, here, or here. But we've already rotated it to fix the pair up at the top, which means that all 3 of these are actually unique. That's unique, that's unique, and that's unique. And then finally, case 3, all adjacent, which clearly only has 1 choice. So that means we have 5 choices in the 4 reds, 3 blues. So if we have more reds than blues, then there's a total of 10 possible different ways to color it, but we can also have more blues than reds, like 4 blues, 3 reds, 5 blues, 2 reds, 6 blues, 1 red, and 7 blues are all the same as these first 4 cases. So we multiply by 2 for a total of 20 ways, which is pretty consistent with this. In fact, you could use a method similar to this by noting that all, okay. As long as you have at least one blue, you can rotate. Like, so let's say we have, okay. So consider all 128 colorings. And other than the case when it's like all blue, when it's all blue, that's certainly one coloring. When it's all red, that's certainly one coloring. And then next you have 126, which have at least one red. And then there's 126 of them which have greater than one red and greater than one blue. And then each of these, there's exactly 7 ways. Like taking any configuration of this sort, you can rotate it, and all 7 rotations will be unique from each other, and they'll all be like, so 7 of these colorings will correspond to exactly 1. So this would end up actually producing 1 plus 1 plus 126 over 7, because those all can be rotated to each other, which equals 1 plus 1 plus 18, which equals 20. 20 different colorings. So there we go, 2 ways to do it. That's how we do it on a real target as well. Do it in 2 different ways and make sure that they line up. I would not trust this on its own, usually. Okay. And that's 215.